All right, this is going to be the numerical calculations that we showed in the previous example for this function, our linear equation from our point B to our point A. So I'm going to show how to calculate that in Excel to kind of show the process both for Excel but also for purposes that we're trying to obtain here. So kind of want to go from start to finish with as much blank screen as possible. To start off with, you'll notice that I've plotted the graph here. I plotted that in GeoGebra, which is what you see here, and I just took that picture and embedded it in here. So that way I have kind of this thing to refer back to as I'm looking at it. So I'm going to start labeling things and typing things in just to kind of get that started. So first thing I want to point is the left endpoint. So this is kind of a thinking about the interval here. Where are we starting our measurement? And so we're going to start right here when our value is equal to 0. So starting from coordinates, our left endpoint A is going to equal 0. Likewise, our right endpoint, okay, where's that? That's B, and B is going to equal for us that value of 4. Okay, so those are my left endpoints, my right endpoints. Okay. To start off with, the number of rectangles I'm going to make in, that does copy that, in, let's try, I think we did 4 on our first class, so I'm going to do 4 rectangles here as well. So for area estimate, it's going to be a little rough, but you'll get the idea. And primarily, I'm not trying to get an accurate result. I'm just trying to get you through the process of how you do that. So then once we have these things established, our left and right endpoints, the number of rectangles, then we can establish then the values for our steps and also the rectangles that will correspond to those to determine our heights for our area. Okay, so our delta x is going to be this is b minus a divided by n. Okay, so that's our delta x value, and so we're going to take that equals. I'm going to write this in parentheses. So if you get equal sign and then parentheses, I'm going to make this a formula in dynamics. So if I wanted to change it later, I can. This is b minus a, which is our number here. And I'm going to close those parentheses and then divide it by the number of rectangles that we have that we're making, which means that our step size will be 1. Okay, and then this will also then come into our xi. And so how do we determine our xi? Well, that is a plus I times, I'll call that the x. I'm going to go back up here and change that to delta square x just so that the labeling kind of stays consistent. Okay. All right. So for us, then this is going to equal a plus delta x, which is here, times I. Now, I'm going to put this in parentheses like that because our value of I will change depending on. So you're going to get this error message. That's what we would do to calculate it. So we're actually going to use this relationship when we do the actual spreadsheet. Okay, so now that we have those, and then the last thing I want to define is our function. So f of x, or yeah, f of x in general, but we were calling it y of x for this particular one, the linear equation. This one is going to equal mx plus b. Actually, it's mx plus b. So we'll have to calculate that, and we got that this was equal to negative 1/2. Write it up here. A negative 1/2 x times x plus 2. Since the y-intercept was given to us as 2, and we found the slope, which is what we did in the last video, the The difference in the y values here is 2. The difference in the x values is -4. -2 divided by -4 gives you the -1/2. And the y value here, let's say mean, should be equals -1/2 x plus b. So here's what we're doing for the areas. So we're going to sum up each of the areas, and so the total of that will be what you see here. That'll be the total area. Over here, the value of the heights will be putting in here, and the delta x becomes the one that you see here. So we only have a picture here because our delta error message. Okay, so let's go ahead and this one and this one correspond. This part right here will be what the base is here, with the xi coming from this value here. Okay, so we're going to plug those in numerically now into our formula or into our calculation here. So let's go ahead and do that. So this one is going to equal our a term. So there's our a, to remember it's equal to a plus I delta x. And so we have our 4 i's plus this term times, that's our I, and the delta x, and our delta x is here. Okay. And let's see, a little bit of notational things. Our C4 is not going to change. So if you go back to this button, hit the button F4, it's going to create, it's going to lock that position in place. We want this one to stay the same. So you'll need to hit F4 here, or use the dollar signs like that. And then E3 change. And C11 also will not change. We're not going to be moving that value. So that one needs to stay the same. So you're going to hit F4 on that one. So the only one that's going to be changing is our I. Okay. So if we drag this down, you can hit D, or the way that we were doing it the other day. If you grab this little corner here, you can pull it down like so. And that will give us each of the xi's. Which happens to be the same. That's because our steps are in units of 1. Okay? So then our height is equal to, according to our formula, -1 divided by 2 times our x value plus 2. So we're going to get that. And again, we're going to drag our value down, and that's going to give us the height of each of our right sides. So here's our first rectangle, and then the second one's here at 2, and the third one's down here. So you can see it's decreasing to 0, which is what we would expect. The base is always going to equal our delta x. So each of our rectangles is the same height, so we want to keep that part the same. And that'll send it down. It's 0 because it's following these values down. And I actually want it to stay. So if I hit F4 here, it'll keep it the same. And then when I drag it down, it'll keep the same value all the way down. See how that works? Okay. So then the area is equal to base, or the height, times the base. And so we can grab that and send it down. Okay. And so that'll give us this height. So the total area is equal to the sum. And then if I hit the left arrow and hold down the shift key, I can capture all those. Likewise, I can also do the same by typing equals sum, and then shift and 9 in the right parenthesis, and then I can highlight this with my mouse and grab all those values as well. Okay, and then enter. So that gives us then that the area is equal to 2, 3, which is definitely an underestimate. We saw that the actual area was 4, and so we see that it's quite a bit off with 4 rectangles approximating. You can see it's leaving off quite a bit. In fact, our whole last triangle or rectangle doesn't give us any value. So let's see if we increase these values just a little bit, if we get a better result. Okay, so let's say we're going to repeat this, but we're going to go with more rectangles. Okay, so let's go ahead and start. We're going to restart our I. 1. And let's say we want to do 10. We're going to go from I equals 1 to 10. So that gives it, actually you can type in this is a cool little trick. If you type in and do the word sequence, that's going to generate a sequence of rows, and I want 10. So type in the word sequence and 10, and it has an issue because there's values there. So once those values are free to use, then we can use that. Okay, and then the xi, remember the xi come from utilizing this relationship. So we'll need to recalculate our delta. So our new delta is going to go here. This is going to equal b minus a. So b minus a divided by our n. We haven't defined that n yet, so we're going to define it until we put a number in there. Okay. And then that will be the only thing that we need. So we're going to have 10 rectangles now. And so you see that's our new delta x. Okay. So our delta x is no longer 1. So we're going to have a lot more rectangles going in. All right. So our xi is going to equal our a term. And if I hit equals, then I just use the arrow keys. That's how I'm going up there. Plus our I term times our delta x. So there's our delta x. Okay. And then you can grab it like that and just pull it down. Oh, right. So that's 0. Our delta x is not changing. I forgot to set those. So our a term is not changing, and then our delta x term is not changing. So each of those values needs to stay the same. That's why we got a bunch of weird zeros and stuff. So let me pull those back up. Pull that down. Okay, and then there we go. So we needed to freeze these two values so that way they're always equal to these two cells, the delta x and the a value are the same. Okay, so those are our right endpoints uh, for the rectangle, and then our height is going to equal. So it's going to be -1 divided by 2 times our xi plus 2. Okay, so that's the height for the first one. And then there's our height of awesome. And our last rectangle, we should expect a height of 0, which is perfect. Our base is always going to be the same, and it's always going to equal our delta x here. And now I'm going to hit F4 to hold that and lock it down, and then I can just pull this down and hit Control D, and I'll duplicate it, and then our AI is going to be that times that. Okay. And sending that down. Okay, so those are all the areas, and so our total area then is going to equal sum, and I'm going to highlight all of those. And 3.6, and our total area should be 4. So you can see already a significant improvement with just increasing the number of rectangles to 4. Okay. So let's say I want to do 50 rectangles. So I'm going to move this over here, and we're going to do 50 rectangles. Okay, so I'm going to copy this. I'm going to copy all of this down here, so that way we can see what it looks like with so B. Oh, okay, let me copy this. Copy this. I'm not sure. There we go. And then I'm going to copy this. All right. So I don't want just 10. I want to do sequence. Let's do 50. I'm going to do 50 values. Okay, so there they all are. And then my xi, well, my a and b are still the same, but now I want, let's be 50. Okay, so this is going to equal a, b minus a, b minus a. I only move the b and a down so that way we can still keep it on the screen divided by our n, which was there. Okay, so those are, so you can see this is a significantly smaller step size. Okay, so now that we have that, our xi. Right, so to calculate the individual values. We're going to take our A term, and we're going to freeze that, so F4 there, and we're going to add to it our I term, and then we're going to multiply that by our delta x, which is here. And we're going to put F4 on the delta x term so that way it stays. Type that in, okay? And then we're going to send that down. If you double click on it, it'll fill it all out. And if you notice that we have it set up right, because our last one should be at the right endpoint, which is 4. So that's really good. Our base here is -1/2 times our height, so that looks really good. So we can send that down, and just we expect for our heights, okay? And our base here is different, so this base is going to equal our delta x here, okay? And so I'm going to put that in F4 so that way it stays the same. We'll freeze it at that value, and then I'll double click it and send it down. Notice it'll send it down to where it needs to be, okay? And then this is the product of these two, which is what we want, and send that down, okay? And last but not least, this is almost right, but we want it to equal the sum of all of it. So we're going to sum and then get all of those areas. And so you can see that with 50, our area is getting much, much closer. So 3.92 is pretty close to 4. Still not exact, but you can imagine if we doubled this, went to 100, it would be even closer. If we went to 1,000 or something like that, you can see how each of these terms gets a little bit closer. So with 10 terms, getting pretty good. With 4 terms, it's not very good. And with 50 terms, it's getting pretty close. Okay, all right. So that's just how to utilize Excel and the process of using the rectangles to sum over to find the area under the curve. In the limit, when n goes to infinity, we obtain the Riemann integral. And the Riemann integral is then, of course, what we will spend the rest of the semester studying. All right, until our next video, I hope this was helpful.